Indonesia, the biggest archipelagic country on Earth. Made up of thousands of volcanic islands, best known for beaches, volcanoes, Komodo dragons, orangutans sheltering elephants, and tigers. The mega biodiverse country is inhabited by 20,000 different kinds of herbs and plants, also place where you can find more than 10,000 kinds of animals roaming the land. Indonesia is homeland to hundreds of ethnic groups speaking as many as 650 different languages. Differences is our motto, made us strong by one vision of a big country. Formerly part of University of Indonesia, in 1963, IPB University was stood as the first independent campus to focus on agriculture. Located in Bogor, West Java, IPB University brings strong vision as a leading international university focusing on agriculture, marine, and biosciences. There are 11 faculties and schools, comprises 39 undergraduate study programs, 65 master study programs, and 42 doctoral study programs. There are 27 internationally accredited study programs in IPB University as a proof of our commitment as a world-class university. IPB University, through its performance, able to craft achievements and acknowledged as the most innovative state university in Indonesia. In promoting students' quality outside the class, student club and societies are places for students of the same interest and hobbies to meet and share.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good afternoon. We would like to extend the warmest welcome to our today's speaker, Professor Anuraga and Professor Despal, as well as all of our dedicated participants. Welcome once again to the 6th academic session for our International Summer Course 2025. Okay, as usually, before we going to the next session, we will capture a group photo. I kindly request all online participants to enable your camera to share your best smile. Okay, please to the all participants for enable your camera and show your best smile. Okay, we would like to see all participants. Okay, we'll wait. Okay, please to all participants, please kindly enable your camera. Okay, we'll take the photo in 3. Okay, wait. There is still another participant. Okay, we'll take the photo in 3, 2, 1. Okay, hold on for the next slide. We'll take the photo in 3, 2, 1. Okay, thank you so much for the photo session. Now, let's get ready to start today's course. I hope everyone excited and comfortable. Please make sure that your microphone is muted during the presentation to ensure a smooth and uninterrupted session. Feel free to use the Zoom chat for questions or comment. Okay, to lead and facilitate this session, we are honored to be joined by our moderator, Dr. Nurrohma Kumalasari, Bachelor of Animal Science and Master of Science. Okay, operator, can please share the CV from Dr. Nurrohma Kumalasari? Okay, let me briefly introduce her. Dr. Sari is a lecturer and researcher at the Department of Animal Nutrition and Feed Technology, Faculty of Animal Science, IPB University. Dr. Sari completed her bachelor and master degrees at IPB University and earned her PhD in vegetation analysis and plant diversity from University of Göttingen, Germany. Wow, from Germany. She currently serves as a secretary of Department of Animal Nutrition and Feed Technology, Faculty of Animal Science, IPB University. Her research focuses on sustainable forage production, functional feed resources, plant agronomic evaluation, and plant exploration. She has also published several works, including studies on indigofera seed production and silage quality. We are honored to have her guide us through this exciting session. Without further ado, please welcome our moderator, Dr. Sari. Dr. Sari, the screen is yours.
Thank you, Raden. I hope my sound is clear. Good afternoon to all of participants. Welcome to our summer course program. My name is Nurrohma Kumalasari, and I will moderating this session in this series of summer course program. Before we begin, I have a few housekeeping notes. Its presenter in this session will have totally for about 40 minutes for the presentation, and I will give an introduction for them. There will be two presenters here, Professor Dr. Anuraga Jayanegara and Professor Dr. Despal, and each presentation will be time about 2 until 3 questions from the participant. And if you have any question from the presenter, please raise your virtual hand and you can turn on your microphone when I call on your name to ask a question. And you can also raise your hand by clicking your name in the list. So let's welcome our first presenter, Professor Dr. Anuraga Jayanegara. And here I will read his CV, his education in animal science, IPB University for the Bachelor Science. He is my classmate, actually. And then for my magister, he studied in agriculture science in the tropics and subtropic at University of Hohenheim, Germany. And then he continued his study for doctorate in animal nutrition, Swiss Federal Institute of Technology, Zurich. and he also take his magister in Islamic education and PhD in Islamic education at Jakarta Islamic University Indonesia, and he is work at Bogor Agricultural University since 2004, 2005, and he is a professor at Bogor Agriculture University since 2021, and he has a lot of publication in Scopus document, and his research interest about ruminant nutrition, meta-analysis, and feed evaluation, also feed formulation. And now you will be hearing a presentation from Professor Dr. Anuraga Jayanegara, who will speaking to us on enhanced understanding of research based on meta-analysis. Professor Anuraga, the time is yours.
Thank you very much, Dr. Sari. Could you all hear my voice? Is it clear enough or not? Okay. Is there any problem with my voice?
Yes, I hear your voice, but
Okay.
maybe it's little lower.
Okay, sorry. Do I need to change the, I don't know, normally it is working well. Is it fine now?
Yes, maybe the technician, can you hear clearly?
Okay,
From
maybe I need to change.
What about now? Okay.
yes,
good.
yes, it's good.
Okay. Yeah. Okay. Sorry. There's a mistake in setting up the device. Okay. Thank you very much, Dr. Sari, for introducing me to all the audiences here. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, all the participants of our international summer course. Within this session, I'm going to talk about the application of meta-analysis in animal nutrition. There are some points that I'm going to deliver. The first one is the background, and then the introduction, the method of meta-analysis, and then some examples from ruminant nutrition, and as well as from poultry nutrition. And if you are interested, we may have future collaboration in the future. So I've been working with meta-analysis since 2010. Yeah, so almost, let's say, 15 years back. Yeah, and so our research group on meta-analysis is one of the leading research group using this methodology. And currently we have published more than 100 published papers related to the use of meta-analysis in the field of animal science, animal nutrition. Some studies also we perform in food sciences and other related studies. Yeah. So the background. Currently, we have really enormous of data. Many data have been generated by different research, yeah, from publication, from industrial research and development, yeah, from research report. So we have been generating a lot of data. Of course, we need to make a good conclusion from the data. So data now is an important tool for making decision. So our decision now is really based on the data. Therefore, it is coming up data science or even decision science. Yeah. And we may also apply this technique to our field of study, to animal science, to animal nutrition. And of course, data from different origins are highly varied. Yeah, the variation is quite high. Yeah, among different studies. And from different studies, for example, if we evaluate certain feed additive, for example, the use of butyric acid or butyrate, an organic acid used for broiler, for example. Some studies reported that this butyric acid is able to impair the growth of pathogenic microorganism in the in the gastrointestinal tract of broilers, but some studies reported no effect at all. Yeah. So how do we combine these different studies? How do we make a robust conclusion from this kind of different studies, different data? Yeah. Therefore, we need to utilize a certain scientific methodology in order to cope with such different variation. And we are entering also the Industrial Revolution 4.0, or in the Japan Society 5.0. One of the fingerprint is to utilize big data. Yeah. And it is also very important for us to forecast and make decision in animal operations, yeah, in animal business and industry. What is meta-analysis about? If you have heard the research synthesis, yeah, so meta-analysis is actually part of the so-called research synthesis. We want to synthesize different studies or different research into a robust conclusion. This is one of the main methodology for performing the research synthesis. Yeah. So research synthesis can be performed qualitatively. It is commonly known as systematic review. So review can be done either narratively or systematically. If you perform the review by using a certain methodology, for example, how do you perform the searching of the literatures? Yeah, how do you use the keywords, and how many articles are generated initially, and what about the screening process? Yeah, if you report this stepwise methodology, then it is a systematic review. But if you don't report the methodology, then it is considered as narrative review. However, the systematic review is, of course, mainly is qualitative. But when we perform the quantitative analysis from the database, and this database is made from different studies, from different experiments, from different data, yeah, it is known as meta-analysis. So this meta-analysis is basically the statistical synthesis of big data, yeah, that are generated from different studies. So we can combine data from Africa, we can combine data from Asia, from different parts of the world, as long as it is sensible. So this is the Venn diagram, yeah. So systematic review and meta-analysis. There is a shared portion in which this one, yeah, being part of both systematic review or meta-analysis, it is the methodological framework. So the methodology is similar, but when it is done qualitatively, it is systematic review, and when it is done quantitatively by performing statistical analysis, it is called meta-analysis. Yeah, so it is basically the quantitative analysis or the statistical synthesis from the meta database. I think most of you are bachelor students, or are there some graduate students here for the participants? Mix,
Both.
both
There
of
are
them, yeah.
some undergraduate and also some
Postgraduate students, yeah. Okay. So maybe it will be a little bit hard for those of undergraduate students, yeah, because yeah, this is not taught, yeah, it is not taught in the bachelor degree, but for the graduate studies, maybe it is not also common to be taught, yeah. And of course, one of the disclaimer here, it is, let's say, like an introduction of this meta-analysis. Normally, if I give training for the meta-analysis to certain universities in Indonesia, for example, last time was in Bandung Institute of Technology. This one is a couple of days, around 2 to 3 days. Yeah, if you want to really understand the meta-analysis, from how to generate idea, how to develop the database, how to statistically perform the analysis. You need let's say 2 to 3 days full. Yeah, 8 hours per day. But here I have to deliver this less than 1 hour. Yeah, so this is more or less like an introductory part. Yeah. Okay. Um, so how to perform the meta-analysis? First of all, you need to have an idea, yeah, what you are going to answer the research question. For example, um, like I said before, yeah, for example, butyric acid. Is it really beneficial, the use of butyric acid as feed additive in broilers? Yeah. Or you may have another research question, for example, tannin. Yeah, tannin, tannin, the polyphenol. If you drink tea, the astringent taste, that is the tannin molecule. Yeah. So tannin, on one side, it is considered as an anti-nutritive factor. So tannin can bind protein on one hand, and it hampers the protein digestion. But on the other hand, tannin also uh, different functional effects, some beneficial effects, for example, as antioxidants, yeah, antimicrobial property, yeah, and some others. Yeah. So when we consider, is it good to use tannin as feed additive, either both in ruminants and monogastrics or broilers or laying hens or poultry? Yeah. If you have such kind of question, you may try to solve the research question by two ways. The first one, you perform an experiment. Okay, I want to check the effect of tannin on broilers. Okay, you perform the experiment, use tannin. Yeah, for example, you perform 3 or 4 dietary treatments to control, and the other 3 treatments with different level of tannins, for example. And then you perform the experiment, look at the parameters, the performance, the gastrointestinal health, uh, the microbiome, yeah, and others. Yeah, that is actually the main way to check whether certain additive is beneficial or not, or functional or not. But then there is another way. Yeah, you gathered all the data, you collected all the data from literatures, make a big database, and analyze the data statistically by performing this meta-analysis. So you can answer this question, the same research question, by these two ways. Yeah, either experimentally perform, which of course need a lot of resources. You need to prepare the barns, you need to prepare the lab, you need to find the funding. Yeah? On the other hand, we may perform also the meta-analysis. We need to have an access to the scientific database like Scopus or Web of Science, or we may also utilize the Google Scholar if you don't have any, if your institution don't have any subscription to any commercial scientific databases. But then the process is quite straightforward. The process is, let's say, zero cost. As long as you have an access to a scientific database and the full text of the papers, this process is really free of cost. You may perform the research, answer the same question, research question, without any cost. This is one of the nice thing from meta-analysis. Yeah. But of course, you need to have a certain robust knowledge of background on meta-analysis. Okay, how to perform the meta-analysis? We have normally we have 5 stages. The first one is the question formulation stage. Yeah, you need to have, that I said before, the research question, and then after you have the research question, okay, I want to see the effect of tannin, for example, and then you try to perform the second stage, the data collection stage. For example, you use the Scopus database, answer some possible keywords like tannin and rumen, for example, or tannin and broiler. Yeah? And then you obtain some potential papers. For example, you obtain 100 papers, yeah, 100 papers. And then from these 100 papers, you try to check the title, the abstract, the keywords, whether they are relevant or not. When they are relevant, for example, from this 100, you have uh, uh, for example, 50 papers are really potential, then you need to read each of them, yeah, carefully. It is free of cost, yeah, free of charge. but you need to spend quite some time to perform this meta-analysis. Okay, for example, from these 50 papers, potential papers, after you read all the full papers, you may obtain, for example, 35 papers that are really relevant. So from these 35 papers, you make a database, an Excel database, quite a big database. And then after making the database, you check the data, the data evaluation stage, the third stage. And then when you are really confirmed, okay, I'm satisfied with the database and already cross-check whether the data are correct or not, when you are satisfied, you may perform the fourth stage, the analysis and the interpretation stage. And once you are satisfied with the analysis, you may perform the fifth stage, the last stage, is the public presentation stage. You may write it in a scientific journal, or you may join certain conferences to disseminate your data. So those are the 5 stages of performing meta-analysis. Okay, now we are going to be a little bit deeper. How to combine different studies? How to combine? Each study has its own characteristic. The setup of the experiment is different. The animals may be also different. The location is different. The environmental factors are most probably different. How to combine all of this variation? From different studies into a single database, and it is valid to be generated for the conclusion. Okay, in the concept of meta-analysis, we need to convert all this data into the effect size. So let's say this effect size is known as a common currency. For example, I have Indonesian rupiah. From Malaysia, you have Malaysian ringgit. From Thailand, you have Thailand baht. For example. But when you are trading each other, you need to use a certain currency, a common currency. For example, okay, let's convert to US dollars. Or I don't like now US dollars. I want to use the euro. Okay, it's fine. But we need to have a common currency in order to be comparable. In order to have a valid comparison among different studies. And the common currency or the common effect sizes in meta-analysis, actually there are many, but here I'm going to introduce you to 3. The first one is the so-called Hedges-D. Hedges is the name of the person who developed this, the Hedges-D, and then the response ratio, and the last one is the meta-analysis based on original data. It is known as ANOVA-based meta-analysis because it looks like analysis of variance. But there are some differences between the real ANOVA and this meta-analysis. Okay, this one is quite statistical point of view. It is maybe not easy to understand within a short period of time. But anyway, I'm going to explain to you shortly. So if we want to compare between different studies, we need to make a relative effect of the treatment to the control diet. For example, this one is the control diet and this one the experimental diet. We need to make a relative response. And this relative can be done into 2 ways. The first one by the difference, by the delta. This one is the delta, the difference between experiment or the treatment and the control. That is one way. And we divide by the pooled standard deviation multiplied by the correction factor, correction term. What does this correction term stand for? It is basically we give more weight for studies with more replicates. That is the basic idea. So, for example, some studies perform the experiments only in 3 replicates or 4 replicates, but some other studies perform in 10 replicates. Of course, we are more trust to those studies with more replicates, right? Rather than these few replicates only. That's the basic idea. Okay, so basically, to use the difference, the numerical difference between the treatment and the control. This is one. I'm not going into detail because if if the workshop is for 2 or 3 days, then I can give you in more detail and some simulation, But within this an hour, so I will give briefly only, Okay, there are some calculation how to calculate the variation, and then the interpretation of the value, what is the meaning of the HSD? What about if the score is less than 0.2? What about if the score is between 0.5 to 0.8? There are some interpretation. And okay, that is the one. And in the second relative comparison between the control and the treatment is by using, instead of using the difference, the delta, we may also use the ratio. Okay, the ratio. The ratio between the experiment or the treatment and the control group. Okay, but then we need to put the ln, the natural, the logarithmic, the natural logarithm, here. Okay, there's some calculation here, yes. Okay, this one maybe too far, but there are some positives, some advantages and disadvantages of using response, the ratio instead of the delta or the difference, of course, scientists are arguing each other whether the ratio is better or the delta is better. But I think this one is the field of statisticians. In our case, we just simply use. When you write papers using any kinds of meta-analysis methodologies or effect size, it is fine normally. Because we are user, we are in the applied side. We are not in the calculation. We are not statistician who derive the calculation. So normally, if I use HSD, if I use ln response ratio, if I use the meta-analysis based ANOVA, the reviewers are normally fine. Maybe those who are not familiar, for example, if the reviewer is only familiar with one effect size only, they may ask you. But if they are familiar with other effect size, then normally the paper is fine. Okay. People from social science, they use the effect size different with people from natural sciences. So they normally use the Pearson's correlation coefficient to integrate different studies. People from social science also normally use the structural equation modeling. They have SAM coefficient. They may also use this as the almost similar to correlation. So people from social science, they have different ways of performing this meta-analysis. I have also experience for the meta-analysis in social science because I took another degree, not in animal science, but in religious studies in Islamic education. In my second PhD, I also performed the meta-analysis, but in the field of religious studies, and it is really different with the natural sciences. Okay, the last one is the ANOVA-based meta-analysis. So we may perform almost like ANOVA, but then different studies, from different experiments are considered as random effect. Okay, this is the main difference between the conventional meta-analysis and the ANOVA-based meta-analysis. Okay, in the common ANOVA, normally you don't use the random effect, but some people may also use this. if they employ, for example, the randomized complete block design, the RCBD. Yeah, you may use this as a fixed effect or random effect. Yeah, but for meta-analysis, you need to put the different experiments as random effect. Why? Okay, this quite complicated. I need more time to explain, but just just yeah, maybe you just believe this for now. Yeah, but of course you may dig deeper. Yeah, from different literatures. So this one is to compare between different treatments. Yeah, and you may also want to compare. Want to check the level. Yeah, whether increasing level of tannin or increasing level butyric acid will lead to linear effect or non-linear effect. Yeah, so you may use this model. Yeah, and also you may use for, let's say, like almost similar to the uh, factorial treatments. Yeah, so you have, for example, two different kinds of butyric acid, butyrate. The first one is the butyrate in the form of acid. The second one is butyrate in the form of butyric salt. Yeah, for example, sodium butyrate. And maybe in the third one, you may have also the esterified butyrate, for example, butyrene, yeah, which is still esterified with the glycerol backbone. Okay, you have three different butyrate, and then you have also three different levels of butyrate. That is the factorial design. And in terms of meta-analysis, you may use also this, yeah. But it is not fully factorial actually, yeah. But you can integrate between different sources, yeah, and different levels at once. And of course, the model is more complex. Okay, I'm going to give you a short illustration concerning the meta-analysis, yeah. So for example, this one is the fiber content of of uh, ration, yeah, different NDF, neutral detergent fiber. Okay, and this one is the chewing activity of cows, for example, yeah, of the ruminants. Okay, for example, we want to evaluate what about the effect of different levels of neutral detergent fiber on the chewing activity of the animals, of the ruminants. Yeah, so you may integrate these different studies here. So these different dots represent different data, and the dots that are connected with lines here, yeah, they are from the same study. They are from the same experiment. Okay, the dots that are connected with lines here. Yeah, so this one is experiment 1, this one experiment 2, experiment 3. Okay, you can integrate for as many as you want. 30 papers, 50 papers, 100 papers. Yeah, once I perform the meta-analysis, of course not only by myself, but with collaboration, more than 200 papers. I think 240 papers, and it is really easily accepted in a top 10 journal, yeah, only within 2 months. Yeah, 2 months, because they are convinced. Yeah, they are convinced with our approach. We integrate more than 200 papers. Yeah, and it is really robust. Therefore, in Q1 journal, sorry, top 10% journal, it is more specialized than Q1. Elsevier, less than 2 months. That's because they convinced. I mean, the journal were convinced to our approach. Yeah. Okay. Yeah. So if you don't perform any statistical meta-analysis, this will be like this. Yeah. Because each experiment has its own error. But once you perform the meta-analysis, the variation due to different experiments are adjusted. Yeah. So from this, it becomes like this. Okay. There are adjustment due to this approach. Yeah. Yeah. You see, it's really different. Yeah. Because all of the dots here have been adjusted due to the variation of each study. Okay. Okay, you see, this one is still a huge variation, but here is less variation because all the variations have been removed. Yeah, the variation due to different studies have been removed. Okay. Okay, this one is very interesting. Okay, what about uh yeah, some examples. For example, in the in the last, I think, 5 years back or 6 years back, Indonesia so far we don't have any let's say comprehensive feeding standard. Yeah, normally we use the NRC, National Research Council from the US for formulating our diets. Yeah, and we refer to those like nutrient requirements released by the NRC for dairy cows, for beef cattle, for any kind of animals. Mostly we use the NRC. Yeah. Um, of course, there are some other feeding standards from different countries, but normally we use. And here, we want to derive our Indonesian feeding standard by integrating local data. Okay, so here we determine the energy and protein requirements of our local sheep in Indonesia. Sheep, yeah. Okay, these data are generated from different experiments and adjusted. Yeah. If you don't adjust this, if you if you analyze without using the meta-analysis, the variation will be very high. This one have been adjusted. Eh? You see the relationship between the dry matter intake and the body weight. Yeah, the initial body weight. Okay, okay here and then this one in absolute quantity gram per day, but this one in relative quantity. Yeah, so basically if you have higher body weight, so the proportion of dry matter intake, yeah, to the body weight decrease. Yeah, so if we use the animals consume 3% of dry matter intake from their own body weight. Yeah, it may be correct, but it is not really correct because it depends on the body weight. Yeah, 3% is for average, but if we have smaller animals or higher or weightier animals, the proportion will be different. Yeah, we can see here from this. Okay, okay. So based on this data and this equation, okay, we check also the interaction for the energy intake as well as with the ADG, the average daily gain. Okay, we could see different patterns for different sheep breeds in Indonesia. Okay, the interaction is significant. So from this data, we could uh, calculate. Yeah, we could derive some equations. So this one, the energy intake of the total breed, local breed, for the Priangan breed and the Fairtail breed. Yeah, okay, these are the equations, and this one is for the protein intake, and we could determine the crude protein intake for different breeds. Yeah, local breed, Priangan breed, Fairtail breed. Yeah, okay. So this one is quite scientific, but then what is important is this one. Yeah, this one is the recommended intake. Okay, if you have sheep with an initial body weight of 15 kg or 20 kg, and then how much is the dry matter intake, how much is the TD and the energy intake, or the crude protein intake is depend on the level of daily gain that you want to achieve. Yeah? For example, 15 kg initially, and then you want to achieve 100 gram per day of daily weight gain, and you have the Priangan breed. Okay, please use this. Okay, formulate your diets by using this standard. And is it really beneficial? Is it really working or not? Okay. Once we perform the accuracy testing, but of course this one is a field study. It is not really it's a under control condition. Yeah, this one we came to a sheep farm in Bogor. They have 500 sheep. Yeah, mainly Priangan sheep. Okay, the breed is Priangan, and then the initial body weight on average is about 18 kg, and the ADG is the weight gain is around this. Yeah, and this one is the information on what kind of feeds are given to the sheep every day. Yeah, during our time there, they gave the corn stover this amount for 500 sheep. Yeah, cassava peels, tofu cake, yeah, and commercial concentrate. So okay, and then we brought the samples to our lab and we analyze for the proximate composition, and then we calculate, okay, the diet contain, yeah, the energy of the diet actually can support around 140 gram per day of weight gain for the energy. But then the main problem is the protein can only support the gain until 50 gram per day. So there's a difference, huge difference between the energy content and the protein content. The energy content is too much. Yeah. So we need to resolve this. We need to balance this. Okay. And the observed gain is between this. Yeah. It means that there is energy wasting of the energy, because most of the energy will be converted into fat. Yeah, if you balance this, for example, okay, I want to balance this one can support to 100 gram, this one to 100 gram, you may get the optimum result. Yeah, again, least cost uh, is not always come to the maximum profit. So you may have a higher cost for your feed, but you may achieve much better profit. So you need to consider whether uh, your objective is to make a least cost of the feed, or to maximum or to maximize your profit. This one is interesting. Okay, so I give you some other examples. Yeah, uh, for example, this one, the meta-analysis on the use of condensed tannin and uh, the protein digestion, yeah, in the rumen. We measure the ammonia and the isosorption fatty acid. We could see this parallel because this one is from the nitrogenous compound from the amino acid, and this one is from the fermentation uh, uh, of the carbon skeleton, yeah, of the amino acid, yeah, especially the branch chain amino acid. Okay. Okay, what about tannin? Yeah, we perform also this. Okay, tannin could reduce from all the data that we gathered. Tannin is effective to reduce the methane emission from ruminants. Okay. What else? Yeah, all of this data are generated from database, from the literatures, and we collected the data and made the database, and then analyzed by statistical and meta-analysis. This one is we observe the effect of using tannin to reduce the proteolysis, yeah, the protein breakdown in the silage, yeah, and it is successful. Okay. Other additive here, for example, 3-nitrooxypropanol. It is a synthetic feed additive to block the methanogenesis, the formation of methane in the rumen. Okay. Here we compare between the, in some countries, including Indonesia, it is sold the organic milk, yeah, milk with organic stem, right? And our question, normally the organic milk is, the price is double than the conventional milk, or maybe 3 times higher. Yeah? But then our question whether this organic milk is really beneficial for human or not. Here we perform the comparison, yeah, by using meta-analysis between organic milk and conventional milk. And we could see that in organic milk, they have more beneficial fatty acids, yeah, or healthier fatty acid profiles. For example, higher omega-3, higher conjugated linoleic acid, yeah, the main isomer of cis 9 trans 11, Yeah, this one is too deep maybe, yeah. But these fatty acids are considered as beneficial fatty acids for human health. Okay. What about in poultry? Okay, once we perform the, just to give you some examples, yeah. In the market, it is available for zinc supplementation for poultry. You may have the anorganic zinc, for example, zinc sulfate or zinc oxide. But on the other hand, you may also find the organic zinc. Yeah. And of course, they have different claims. Yeah, okay, anorganic is cheaper, but organic zinc is more available. The forms is more available. Okay, just compare this, prove it empirically. And here we could see that both of them are effective, yeah, to improve the performance. We could see that both zinc forms, both organic and inorganic, both of them are able to decrease the feed conversion ratio. It means more effective for the production performance, but there is no difference between these two forms. Okay. So we can simply this. Even if you are working in industry, it is important also to consider what kind of additives or what kind of supplements they are more useful. Yeah. So it is not only important scientifically, but also for industrial sector. Yeah. Okay. What about the in poultry? It is very common or almost always, yeah, to have amino acid supplement. Yeah, for example, methionine. But then methionine supplementation can be done by using dextrolevo DL-methionine or with methionine hydroxy analog. But then the question, which one is more effective? Yeah, uh, of course we need to separate between the biological effectivity and the cost. This is something else, but at least we may know the comparison between these two sources of methionine. Okay, from here it is very clear based on ADG, based on gain to feed. It is clear that the DL-methionine is more effective than methionine hydroxy analog. Yeah. Okay. But what about the cost? Okay, you may perform different analysis based on the cost. Yeah, separately, and make your decision. Yeah. Quite a number of studies that we have performed. For example, here the garlic supplementation for a broiler, and this one is if we want to supplement our laying hens. Yeah, now it is quite popular here in Indonesia to have eggs enriched with omega-3, right? Omega-3 rich eggs, for example. But then the question, if we are working in animal science in laying hens, which sources of omega-3 is more effective to enhance the omega-3 in egg, okay, from the diet transfer to the eggs. Yeah. Which one is more effective? Then, okay, rather than performing the experiments, we just collected the data and analyzed them, and we may see whether fish oil or algae is more effective or not. Yeah, which one is more effective, and also we can compare also the cost. Here for the flavonoids, yeah, it is now quite promising. Yeah, so getting interest to supplement or to add plant secondary compounds or plant functional compounds into the diet of poultry, in broilers, in laying hens. Yeah, for example, here's flavonoids, and in some other papers that tannin may be also used, or saponin. Yeah, this one is probiotic for laying hens. So basically, you have numerous ideas. We could perform the meta-analysis. Any kind of idea. Okay. Fortunately, our research group here in our department for the meta-analysis used in animal nutrition or in animal science in general, our group is the most productive group in the world. Yeah, fortunately, yeah, we are number one for the meta-analysis studies in terms of publication in uh, well-respectable journals, yeah, indexed by Scopus. We are number one based on the authors. And for the institution, IPB University is number two, yeah, after the INRAE, yeah, the Research Institute, Agricultural Research Institute in France, yeah, because they are really specific in research. Yeah, they use meta-analysis quite often. Yeah, we are above Guelph from Canada. We are above Wageningen from Netherlands. Yeah, and some other universities. So I think this is one of our strengths. And of course, I'm quite open if you are both students or lecturers from different universities or countries would like to have collaboration with us. Please feel free to contact. Yeah? This is my email address. Okay, I think that's all of my presentation. Thank you very much for your attention. Thank you. Yeah. Please, Busari, back to you.
Thank you, Prof. Anuraga. Thank you very much for addressing this interesting topic. And it is very important, I think, for all of us. And this topic opens a lot of opportunity for collaboration because meta-analysis is one good tool for research with low cost, I think. Although it's already started some years ago and it is still very popular and easy to accept in journal. And then I open a question. Please raise your hand and add your question because we have just maybe 5 minutes. So if you have a question, please. Maybe some of you want to collaborate with Prof. Anuraga. There is Zaidan Jauza Akila. Please give a question for Prof. Anuraga.
Okay, thank you. So my name is Zaidan and I'm currently moving into my third year as an undergraduate student in biotechnology and food nutrition at National Taiwan University. So because your presentation is
What is
quite
your
difficult for
university,
me,
Zaidan? What is your
uh,
university?
Nation National Taiwan University
NTU.
in Taiwan. Yeah, NTU.
Okay, but are you Indonesian or?
Yeah, I'm
Oh,
Indonesian.
that's
I'm
great.
studying
Yeah.
there.
For your bachelor or master?
Bachelor,
Bachelor. You know Dr. Lin
bachelor.
in poultry nutrition? Dr. Lin?
What
Yuan
Lin?
Yuan Yulin. Dr.
Oh,
Yuan
Yuan
Yulin.
Yulin. Oh, I know her, I know
Okay,
her, I know her.
okay,
I know
okay.
her, I
We
know.
have collaborated for some papers, yeah, in poultry.
Oh,
Okay,
I see, I see, I see, I see, I see, I see.
okay. Please continue,
Okay.
Zaidan.
Okay, because your presentation is quite difficult for me because I'm a undergraduate student moving from second year to third year. But I've been learning from software introductory courses such as like bioinformatics, database system, machine learning, big data, Python programming, and some basic statistics, also R code. So in my bioinformatics class, I was introduced like the topic like genome annotation, NGS analysis, and also the molecular evolution. So I also joined a few workshops and seminars that helped me to understand how these tools are used in biological research. Even though I'm still confused, like what is what is this and what is the my professor used this kind of the data analysis to propose some product or some paper. So I'm still trying to connect what I've learned with real research application. And I have question. In the context of meta-analysis in animal nutrition, is it possible to include genome annotation data from NGS to better understand how animals respond to at the molecular level to different types of feed, like fermented byproducts? Also, someone while learning Python, I'm curious, can we use tools like Pandas, Beautiful Soup, or Bio.Entries to help collect and organize literature data from NCBI or PubMed to build a data set for meta-analysis on the effect of dietary tenants on methane emission? Because I'm still curious, like, what is the purpose of this method? So I want to know more about this one. Thank you, Professor.
Okay, just directly, Busari.
Yes, please, Prof.
Okay, so very interesting, Zaidan. Yeah, of course. During your bachelor degree there, you are given a lot of courses, yeah, related to data analysis. Yeah, maybe you learn also the experimental design and different tools for data analysis, and you also learn the omics technologies, right? Together with the data analysis. Okay. So for the omic technologies, you have the genomic data. Yeah, you have also after gene, then you have transcriptome. Yeah, transcriptomic, and then from to proteomic, and then finally to metabolomic. All of this use a lot of data. Yeah, but of course, data from different biological processes. Okay. So for the let's say the overall omics data or bioinformatics, you need to utilize of course they are complex database, but the database is the omic, for example, the genomic is from DNA, yeah, the transcriptomic from the mRNA, yeah, the proteomic from the protein data, and then the metabolomics from the metabolome. Okay, this what is the difference between this and the meta-analysis? Yeah. Of course, all of them are data. Okay, all of them are the same with regard to the data, but the meta-analysis, the main difference. Yeah, the meta-analysis, we combine data from different experiments, from different trials. For example, I performed the tannin trial, yeah, of two broiler here in Indonesia. My colleagues, for example, from Brawijaya, he also performed almost similar study using tannin to broilers, but the experiment was done in Malang, in Brawijaya, and Dr. Lin, yeah, Yuan Yulin, in Taiwan, performed also almost similar study. So these all almost similar studies or the same topic, evaluating tannin on broiler, yeah, from different papers, of course, different experiments are combined together. So we then perform a global analysis on the effect of tannin on broiler. So the strength point that we perform the analysis, yeah, based on comprehensive database, not only from one single experiment, but from many different experiments. That is the strength point, with all the variations in the data, in the database. Yeah. So again, the meta-analysis, the main fingerprint is that it is data from different studies, from different experiments. But when you perform the bioinformatic analysis, yeah, for example, the metagenomic, okay, or the transcriptomic, they are normally from single experiment. Okay. What about if if you try to combine this data, for example, the genomic data, yeah, into meta-analysis, is possible or not? We have performed before. When I look at the paper, because I have in my database 300 something papers, I could not find. Yeah, but once we publish a paper in Frontiers in Microbiology, because at that time one of my colleagues in National Research Institute, yeah, from BRIN, they have question regarding certain additive modulates the microbiome in the gastrointestinal tract. Yeah. Okay. So we collected data from the microbiome analysis, the metagenomic results. Yeah, we take some data, not all, because they are very complex. So the targeted data, and then we integrate into the database and analyze them statistically. So it is also possible to integrate between the omics data and the meta-analysis. The omics data normally for each experiment, single experiment, but when you combine different omics data from different experiments, then it is the meta-analysis of the omics data. Yeah. Hope it is clear for you.
Yeah, thank you,
Okay.
Professor. It was clear. I
Yeah.
understand.
Okay, thank you,
Thank you,
Zaidan.
thank you.
Thank you for Zaidan. Prof. Anuraga, can you answer one question again, because it's
Okay.
already Fadila Sehu Nuhu from Nigeria.
Okay.
Yeah,
shortly, yes,
she
of course.
already raised her hand. Please, Fadila.
Fadila and Liana, 2 questions, yeah? Maybe short questions are fine.
Hello, good morning.
Good morning in Nigeria.
Yeah, yes. My name is Fadila Nuhu Shehu. I'm a PhD staff in training from National Agricultural Research Institute, Ahmadu Bello University, Zaria, Nigeria.
Okay.
It's a very nice presentation. I enjoyed the presentation. My area is animal nutrition. I specialize in monogastric nutrition.
Okay, very nice.
So,
Yeah.
and my research interest is I use broilers, alternative feed ingredients, their composition, anti-nutrients, processing method, all this. So it was a very nice one for me. And I also want to collaborate. I saw your email. I will surely send a mail to show my interest. And my question, I think I dropped a question in the chat box. Is there any difference between short chain fatty acid and volatile fatty acid? Because in the course of your presentation, I heard you saying the short chain fatty acids are breakdown of protein. So in my own
Okay,
knowledge,
yes.
I know volatile fatty acid, which is from the ruminant fermentation. So
Yeah.
I know the volatile fatty acid are the breakdown of carbohydrates. So I was thinking, is there any difference between these two, small chain fatty acid and volatile fatty acid? Thank you very much for the presentation. It was very interesting. Thank you.
Okay, nice, Fadila. Yeah, hope we can collaborate in the future. Yeah, just send me an email. I will answer you from the last question first. So basically, the volatile fatty acids and short chain fatty acids, they are same. Yeah, but it is different from the perspective. So short chain, yeah, short chain. It means that the chain which is short. Yeah, normally people consider short chain as uh, number of carbon 6 or less. So you have acetic acid, yeah, acetate, yeah, C2. The number of carbons is 2, propionate is 3, yeah. That is short chain fatty acids. But when you consider the volatile fatty acids, they are the same. They are talking the same things, yeah. But uh, but one is referred to number of atom of carbons, yeah, number of carbons. But on uh, the volatile fatty acid refer to its property, the property. So the short chain are volatile. Okay, so basically they are the same, yeah. Don't miss perception. They are the same, yeah. But normally people use the VFA, volatile fatty acid, in ruminant nutrition, yeah. But for short chain fatty acid, normally in the gastro in the lower gut of broilers, right? Yeah. So they are the same. Yeah. So if you look at the profile, it is talking about acetic acid, propionic acid, butyric acid. They are the same. Yeah? Okay. And the other one is yeah, of course, it will be great, yeah, to have collaboration with you. For example, we perform also like this, yeah. Uh, yeah, this one it is yeah, some of the ingredients, especially in broilers, if you use local ingredients, maybe all of them are not well digested in the digestive tract of broilers. For example, still some anti-nutritive compounds, for example, the non-starch polysaccharides, right? Yeah. So here we just simply want to check whether the extrusion, yeah, the processing using the extrusion methodology, extrusion technology is working well or not on the performance and ileal amino acid digestion in broilers. This is one of the example from many others. So please feel free to contact, yeah, Fadila, yeah.
I contact because
Okay.
all the topics discussed are in line with my area of interest in research. Thank you very much.
Okay, thank you, Fadila. Okay.
Thank you. And once again, I think Raga have time for Diana, please.
Okay, good afternoon, sir.
Yes,
Um,
Liana.
this is my first time. Before that, let me introduce myself. My name is Liana Wahyuni. I'm a feed quality supervisor at the Agriculture and Livestock Department of Musirawas Regency
Ah,
Government.
Musirawas.
So, but my basic is chemist. So first, I want to know what the different meta-analysis and study literature. And,
Yeah.
and as I know that every research have a ingredient, treatment, and condition different.
Yeah.
So what can we combine the result with the different condition? Thank you, sir.
Okay, thank you. Yeah. Uh, Liana, your background is chemistry or biochemistry or biology?
In organic chemistry.
Organic chemistry. Okay. So I understand your point. Okay. Um, so of course, each experiment is different. Yeah. But when you want to have a more robust conclusion, you cannot rely on one experiment only. So, for example, you try to analyze, for example, you are working as a feed quality assurance, ya?
Yes.
Wastukan, betul?
Yeah,
Wastukan?
Wastukan.
Okay, Wastukan. Yeah. Because I know so the head of BPMSP, you know BPMSP in Bekasi, the Central Institute for Testing of Feed Balai Pengujian dan Sertifikasi Mutu Pakan. You know about this?
No.
That is a central
Because
laboratory, yeah, in
oh, I
Indonesia, yeah.
see. Because I joined Wastukan for 2 months.
2 months. Okay, okay.
Yes.
I get your point. Yeah. So we are in good collaboration with the BPMSP because the head of BPMSP was my previous master student. So okay. Of course, uh, each experiment has its own condition, yeah, different environmental factors, yeah, different maybe for example, different temperatures, different uh, pH, yeah, and others, yeah. But how can we integrate this data? We can make the global analysis across various environmental factors, but we can also analyze the each categorical of environmental factor. For example, we may perform, okay, what about the result when we perform at different range of pH or different range of temperatures? It is possible. So we just need to make a good database. And uh, in meta-analysis, the results are separated into three parts. The first one is the global meta-analysis. This one is to see the global effect. And the second one is the subgroup analysis. That is what I mentioned. You can also compare between different conditions. Yeah. For example, I want to see whether this is working well at different pH range. Yeah. So we can separate the database. Okay, this low pH, moderate pH, high pH. It is very possible. Yeah. Depend on our database. And the third one is the meta regression. We can analyze at different levels, yeah, for certain additive or certain compound, yeah. So I think meta-analysis is really flexible. It's depend on your how you build your database, and then from the database you analyze them, and it's really practical, uh and it is the only way uh aggregating data from different studies. This is so far is the only way. this, this is the So people, the main users of meta-analysis now worldwide is the people from the field of medicine. So if you, for example, use a certain medicine, yeah, we cannot rely on one single experiment. Okay, this medicine is working well. No, it is not enough. You have to perform. Okay, I performed the new drug development. Yeah, a new medicine here in the Musirawas, and then perform the experiment in Bogor, in Jakarta, in Bandung, and then you need to combine all this data. So people from medicine are heavily related to meta-analysis. They call this as evidence-based medicine. Yeah, people from medicine. If you have heard the evidence-based based medicine. Normally, it is related to the use of meta-analysis in evaluating different drugs or different medicines. So it is in chemistry. It is also the same. Yeah, yeah. Of course, you can
Okay.
learn more. Yeah, step by step. Of course. Yeah.
Thank you, sir.
Okay. Busari, it's okay. It's already the time for Budespal or still mute, Busari? Still mute. Maybe you forgot to open your mic.
Yes, I'm sorry. I forgot open my mic. Yes. We already in 14 and already Prof. Despal already here. Yes. I think thank you for Prof. Anuraga, and we give.
If you there's a question, but from Emily. I think Emily from the Philippines, right?
Yes.
Okay,
Emily from
you may
Philippines.
contact me directly, Emily. I think we have met before when you were here in Bogor. So now the time for Prof. Despal.
Yeah.
Thank you, Bu Despal. Thank you.
Yeah,
Welcome.
thank you,
Sorry,
Prof.
thank you very much.
Anuraga, and we give appreciation for Prof. Anuraga. Thank you very much. And we are welcoming Prof. Despal, our second presenter, and she will talk about big data also, develop database to control feed quality and sustainability in Indonesia. I will read her CV, Prof. Despal. She is a graduate from IPB University for her bachelor, and then her magister and PhD from Göttingen University, my senior, and also my supervisor. And she already worked about from 1996, and she has a lot of publication also in Scopus and a lot of international journal article, and she has a lot of research interests to develop the concentrate standard forage conservation, development of local database, and we will run a lot of about database here. So Prof. Despal, the time is yours.
Thank you, Busari. Hello, good day to everyone from wherever you are join, and hopefully we can discuss and fruitfully. And thank you for the committee to give the opportunity for me to share my experience in developing a feed database. Today we will discuss about this topic, and before we start I will work through the content what we will discuss today. It's a comprised 5 section. The first is about the introduction, and then feed quality and sustainability, and also about feed database development, how we build the database, and then we will see a little bit about Indonesian cases, and then also how strategically we develop for the future. And in the introduction, we will discuss about the objective, what will you hope for this lecture, and then why the fit matters, and then the challenges Indonesian facing in this feed sector, and also the role of database in agriculture as in general. And for today, we can hope that we will achieve our goal to understand the urgency of controlling feed quality, and also to explain the basic concept and essential component of feed database. And then we will introduce the method for evaluating feed quality, and to examine the current challenges and opportunity in developing feed database. And with the sustainability concept, I will also introduce some parameters related to the sustainability in the feed database, and also to provide practical insight how to design and how to maintain the feed database. We move on with the why the feed matters, yeah, because in animal farming, feed is the biggest variable component for the cost, and in smallholder farmers, sometimes it can reach up to 80%, and in large farm, it can up to 70%, yeah. And this is not only about the economic impact, but also determine the production, the quality, animal health, and also human health that consume the product. So therefore, the feed is a really important part to sustainable farming, yeah. And poor quality feed, it will lead to inefficiency, environmental risk, and also the harmful for the animal and the human that consume the animal product. So feed is the biggest factor that determine the sustainability of the farm. Challenges in Indonesia, like other tropical area, we have a seasonal variation in feed availability. For example, during dry season, we found many forage because the grass will grow rapidly. There are a lot of water available and sunlight, and it's combined with the high photosynthesis, then the grass will grow faster. Therefore, we can get more forage. But if farmer try to cultivate more land, then they will more forage, what you call it, available that they cannot conserve, because if they try to dry the forage during the rainy season, then it will be difficult because it will be mold, yeah. But if they try to use the for example, wet preservation like silage, it's also difficult because tropical forage usually contain low water soluble carbohydrate that needed for the microbe to acidify the forage. So this seasonal variation is very challenging. And also we highly reliant on agro-industrial byproduct, which is very lignocellulosic material, and it's difficult to digest, yeah. And also as a byproduct, the quality is depend on the main product. For example, corn, if it is for sweet corn, then the quality of the byproduct is still good. But if it is for the hybrid corn, for example, then the forage is very low quality because it's already late mature. And also we have a limited access to the accurate feed composition data because not so many institution can provide data for accurate composition. And some area even don't have access to basic services for the laboratory, yeah, infrastructure. So sometimes they need to send to far away to analyze the basic nutrient content, and it's sometimes difficult to get the best timing and the best quality of their feedstock, because if they send far away, maybe in laboratory it also takes 2 weeks to analyze, and later, and when they use it for formulation, then it become too late, yeah. So what we need now is the real-time data that we can include in our decision making, yeah. And therefore, in database is really important for, especially for precision feeding, where we need to gather the data on daily basis, so that we can include in the decision every day. So we need to have the instrument how to gather the information on the nutrient content of the feedstuff on daily basis. And this also the database also enables to trace the feedstuff, where the feedstuff come from, then so that we can plan for next what feedstuff do we need to grow, so to fulfill the requirement, national requirement, regional requirement, provincial requirement. So if we have a database, then we know the production and we know the requirements, so later on there will be no overstock or low understock feeding available. And with database, we can also connect researcher, farmer, and policy maker together, so that we can build together. For example, in different area, different institution, they have a different equipment. But if we put all of this into one single database, everyone can check and cross-check their result, yeah? They can compare, and it's also promote a transparency. So if we have a lower result, maybe we can discuss what happened. Maybe it's something problem with the instrument. And now we will go to the second part. It's about feed quality and the sustainability concept. Maybe most of you already know what the quality mean, but later on we will discuss further not only the nutrient content, but also many other part of the quality will determine or defining the feed quality. The first is the nutrient content, and the second is how the nutrient will be utilized or digestible or palatable. And the third is the existence or absence of harmful substance, and then the safety for the storage, which lead to their stability. Yeah? Some rich nutrient, for example, it will be useless if they cannot be eaten by the animal. For example, it's a very bad smell, or it's lower digestible because it's binding by certain chemical, or maybe it's a good quality and high digestibility, but there are some, for example, mycotoxin inside, then it's also useless. Or some, it's already good nutrient quality, digestible, and no harmful substance, but it cannot be stored under room temperature, which need more what you call it, a storage measure to guarantee their quality. So this also reduce their feed quality. We need to choose which quality of feed, which feed that we want to include our ration, not only based on their nutrient content. We need also to consider their utilization by the animal, and then also their safety, not only in storage, but also the existence of this harmful substance, because some this harmful substance may transfer to the product, for example, in milk. Yeah. And then this is some key parameters in the nutritional. Dry matter is the basic, where we can calculate all the other nutrient, protein, total digestible nutrient, which express their energy availability. And NDF is the minimum requirement for ruminant to keep the rumen in the healthy condition. And ADF, yeah, which determine their digestibility, inversely related to digestibility. The higher ADF, the lower digestibility, and also macro micronutrient content. So database should provide this at least key nutritional parameter. Of course, there are many other nutrient in. Oh, sorry, I forgot to mention that what I discussed here, the feed database is referred to the dairy nutrition. Yeah, so I'm dairy nutritionist. I always talk about the dairy feed stuff, not about monogastric like poultry. Yeah, but it can also apply. The concept can be applied. But all the example, and for example, the key parameter nutritional I mentioned here is for the dairy. And the contaminant, as I mentioned before, like mycotoxin or anti-nutritional factor like tannin, saponin, alkaloid, high lignin, silica, heavy metal, all these factor can reduce the quality of the feedstuff. And now we want to discuss about the quality related to the sustainability, because even we can get a high quality feedstock, but if it is produced by the high carbon and water footprint, then it will be blamed for the what you call it, environmental by environmentalists. Yeah, for example, soybean oil meal is the best crude protein sources in Indonesia nowadays, but all the soybean meal is imported. So if we calculate the carbon footprint to produce 1 kg of milk but from the farm with soybean meal based feedstuff, then it will be very expensive, because we will calculate the transportation cost from Latin America. And also the water footprint is also very important, how the feed is produced, yeah, how many water is used for the production. And also we consider the economic aspect, yeah, the cost effective one versus locally available. Sometimes the imported feed is cheaper than local. For example, corn, if we import it from Brazil, for example, is cheaper than when we produce locally. But if we calculate the carbon footprint and water footprint, then the local corn is cheaper. But who will gonna pay the price, yeah, the different price? And also the good feedstuff should be socially acceptable, safe for animal and consumer. For example, the feedstuff that cannot be handled easily, for example, the soak oat grain, which is used for the alkaline treatment, is maybe harmful for the human that handle it. And we need a very special caution in handling this feedstuff. And therefore, the quality will be reduced, yeah, because we need extra care, and we need also a budget or cost to handle the feedstuff. And this is the indicator sustainability. Maybe we can use the feed conversion efficiency. For example, how many kg of feedstuff is used to produce 1 kg of milk, and also the carbon footprint per kg, how many area and water is used for the feed production. We can also include all this information in database. So if we do the formulation later, we can choose not only least cost, but also the best sustainable indicator. And in choosing feedstuff from local and global, as I mentioned before, global feedstuff, for example, imported soybean meal, corn gluten meal, or other, for example, barley hay or alfalfa hay, the quality is very stable, and then the variation is very low. In comparison to local feedstuff like rice bran, pumpkin cake, and forage, the quality is vary greatly. But if we calculate the carbon footprint, then imported soybean meal maybe is more expensive. And these pro cons in terms of cost, availability, and sustainability, we need to consider for long-term sustainability of farming. And here we need to monitor, yeah, the database, how we monitor it, and then how we can use to improve the productivity and animal welfare. Yeah, this is as I mentioned before, that feed database is needed for ration formulation. The main goal is to provide the data for ration formulation. So if we use the precision farming, we need to formulate the data on a daily basis. So therefore, we need the real-time data. And if we have the database, the real-time data, we can easily correct it if there is a problem with the nutrient. For example, in the formulation, if we found the end result of the formulation is lower than expected because of the batch feedstock is on a lower quality than usual, then we can correct it directly. If we can have the information, we can have the ability to test on real time. And it's also the stable nutrient supply can also improve productivity and animal welfare. On the third part, I will explain how we build the database. We have a very long experience in developing database, but so far we don't have a stable database yet because the data is still moving, and every adding information will still significantly different from the previous one. NRC, for example, the stable database, it's produced from more than 1,000 analyses for each individual feedstock. So we need to evaluate more feedstock from different areas so that we can get a stable database. Database is not like a feeding table, not a simple feeding table, yeah. It's not only about nutritional value of feedstock, but it's also we can also include this physical characteristic, or sometimes we can also put indicator, and most importantly is we can also put the traceability, where the feedstock come from, what age of the feedstock have been harvesting, so that every people who want to use it will know how to choose which feedstock is most represent their feedstock. And this is several example database that available. It's from INRA, NRC. Now it's not NRC anymore. They changed the name into NASEM, yeah, NASEM. This is the widely used in global feedstock, yeah. And CBV from Netherlands, they also produce a database, and from UK, but all of this database based on the temperate feedstock. So if we want to use our tropical feedstock, then the information is not available or less relevant. So we need to produce our own feed database. Yeah. From my experience using NRIS, we purchased 2 database from Switzerland, and the database cannot measure the local feedstock accurately. Not only the composition fail, but also the information available is also very limited. Yeah. So if we want to develop database based on our own need, for example, more information about the fiber fraction, then we need to develop our own database. As I mentioned before, what standard parameters should be included? That's nutrient content, mineral, and also utilization of the nutrient. And if we want to targeting produce, for example, some functional milk, we can also include the bioactive component in the feedstock, or antioxidant, or something that we need to calculate in the produce something. For example, if I want to produce milk high in CLA, of course, I need to know the linoleic or linolenic acid content in the feedstock so that I can calculate how many percent will be biohydrogenated and how many percent will be remain and as a precursor for the CLA. So this specific need for database is also good, but as a general user, and we need at least this nutrient content, mineral, and characteristic of their fermentation. For example, how many percent will produce methane and metabolizable energy, net energy, and so on. And also the traceability, where the feed come from, what year, what season, and then how many harvests already done. For example, forage, young forage, and the first cut and second cut, and so on. It's also influence the quality. And then how we evaluate the quality. The gold standard is wet chemistry. But again, it takes time, yeah, for the complete proximate analysis. For example, regular method require 1 week. And this is if the laboratory capacity high, then they can analyze quite a number of sample. But if the capacity is low, then there will be a long in line to wait for the analysis. And now we develop the rapid analysis that can analyze the nutrient content, digestibility, and so on in 1 minute. So in 1 minute, we can analyze all the chemical standard as long as we do the what you call it, the calibration. At the beginning, in developing this database for NRIS, we need also to analyze the feed chemical using wet chemistry analysis. And then we put into the NIRS, and then with the after NIRS we have, it's using machine learning, they can analyze and estimate the composition, and in 1 minute the result will be come up. So NRIS is very suitable for daily use and for the large number of sample. Usually large feed mill use NRIS for analysis the feedstock. Even in feed mill, they can use many type of NRIS, yeah, at-line, in-line, online. There are many type of NRIS that can be used. And also we need to analyze the utilization of the feedstock. Sometimes we need to use in vitro or in situ for determine the digestibility and potential. Or sometimes if we want to see the kinetic, when we want to know that the nutrient will be fermented in synchronized, then we can use the gas production technique. And there are many other method to measure the evaluate the feedstock. And for all of this data, it will be more useful if we can integrate it into a digital tool. For example, cloud-based, yeah. If we can put the database on the cloud, and then we can share with other people from widely area. And also we can use the mobile application where everybody can input the data to enrich the database, yeah. And also using the AI, we can predict which data is outlier, and also we can reduce or remove the outline data or anomaly data. And with the what you call it, a user-friendly dashboard, we can invite everyone to join the database development, because many laboratory do the regular analysis. For example, the lady from before that asked the question from Pak Anuraga, yeah, work in the feed laboratory analysis, yeah. If all the data can be put in the database, then it will enrich the database system. For example, if we have 1,000 data, and then plus 1, even this one data is very what you call it, tailing to the right from the normal curve, if we sum and then make the average, then the data will fall into the average. So until we have the stable database, even the outlier data will not disturb the average. So we need a large number of data to build the database and the stable database. Yeah. And later on, and then we can update it, and then with a new invented feed stuff, for example, or new introduced feed stuff, we can add some more feed stuff into the database. Yeah. And this is, for example, the entry data, yeah, so that everybody can join the entry. For example, we can put the feed name, the region where the feeds come from. Then we will put all the nutrient content, and then the unit should be standardized so that everybody that entry the data will know how to put the data. Yeah. For example, the dry matter basis, yeah, all the data should be under dry matter basis. So not everyone what you call it, interpret the data. And then we can also put the in the metadata so that we can analyze the data later on, and then we can see which one should be exclude, and then which one can be put in the system, yeah, to enrich the system. This, if everybody can join the entry, then from their laboratory, then we can get the large number of sample faster. One of the project that currently we run is from project from UC Davis, yeah, collaboration with UC Davis, and this is also multi-lab and multi-country analysis, so that later then we will get the stable database. Yeah. And before we put into the database, we need to check the quality, whether the data is valid or outlier, and or we need calibration. And then we need also the cross laboratory check, whether with the different equipment will result it in the similar or almost similar data. And then also we need to document it, the analytical method, if later on we found a different result. So then we can make a regression or collaboration to check or to correct the outlier, or to transfer, or to make the value almost similar. And then this database need to be maintained and updated, yeah, because as we already know that many feedstuff are developing, and then to be included and used by industry, we need also to update our main database, yeah. And this database can be also accessed by public, but due to the cost, maybe some data, complete data is restricted for the what you call it, premium consumer. It's also normal for database, yeah. If we want to access, for example, you can all of you can use ChatGPT for free, but if you want to get better result, you need to register and pay, yeah. And this database for feedstuff, it's also the same, yeah. I can see and I can use the NICEM database now, but if I want to get a better result, I need to register and pay yearly. And this legal institution is also need to be what you call it, be there to protect, and then to as a quality control, yeah. For example, if we work with the government, and then maybe government can also provide the networking and also instrument with similar standard. For example, from the BPMT, yeah, in Indonesia we call it BPMT, where the feedstock analyzed for commercial company and so on. And in each province, I think they have a BPMT, and this BPMT with a national standard, and we can get a similar instrument and also a similar result. If all this data can be collect and nationally, and then later after certain period we will get a database. Yeah. Now we move on with the Indonesian cases. Like I mentioned before, in Indonesia, we use for dairy locally available rice bran, pumpkin, tofu waste, cassava peel, and so on. Yeah, for the grass, we use corn stopper, and this is mostly from the byproduct of agriculture, and they are vary in nutrient content. Yeah, and this is our study. Yeah, from different local database. Data feedstock in comparison to the Australian grain, and we see their price relative to their nutrient content. Yeah, there are many. For example, here local data feedstock is also quite competitive. Yeah, for example, which one? Pumpkin meal, PKM. Here it's quite good. Yeah, low protein price, low energy price. So this is quite competitive in comparison to the Australian grain. Yeah, many local feedstock is quite good. Therefore, it's used widely for the dairy. Yeah, this is Indonesian the black one is for Indonesian data feedstock, and the red one is from Australian, because this study is a collaboration with Australian grain. We compare the Australian grain with Indonesian feedstock because they want to enter Indonesian market. We need to study their price relative feedstock. Yeah? And this feedstock, it's also regionally variable. And like here from my research, and the variation even in the same regency, we found a very high variation in the quality. Yeah, in this is in one district. Yeah, you can imagine the different district or even different province and different condition, because Indonesia is very wide, and their ecological typology is also very different. So you can imagine if we have a one single database that cannot be used from one place to another place. So it is very, very difficult to develop database that can cover different ecological variation of Indonesia. And current practice, mostly the smallholder farmer did not formulate their own ration, but cooperative helped them to formulate. They only be told how to give the how to feed the animal. For example, for the dairy cow, it's a simple formula. For example, you need to give 10% of grass on daily basis, and then 2 times of half of their milk for concentrate. For example, cow with 400 kg body weight, they need to be given 40 kg of grass, and then 10 liter of milk, they need to be given 5 kg of concentrate. This is formula usually told to the smallholder farmer. But large farm, they do their own formulation, and therefore they need feeding database, feed database, yeah, for the good formulation. In Sumatra, it's even worse, yeah. Not many cooperative that can assist the farmer group, yeah. Sometimes they only have extension services from government, local government, but it's not intensively advise the farmer like in the cooperative, yeah. So for the local smallholder farmer, usually they don't use the feeding table or feed database because they don't mix their own ration, yeah. It's already given by the or advised by the cooperative, because even the concentrate produced by the cooperative. But for the large farm, usually they produce their own feedstuff. This is the some of the data of variation of grass from different area. For example, this is a natural grass, yeah, or rice straw from one place to other place. For example, this is vary greatly, yeah. Cornstopper is also vary greatly. This is cornstopper and this is also cornstopper. So the quality is very greatly from one place to another place because it's a byproduct, yeah. It's depend on the main product. If the main product harvest very well, then the residue will be less. So the quality is very low. The more advanced technology to harvest or to process the main product, then the less residue will be available for forage or for the animal. And this is our current project, how we develop database, yeah. We develop many database for NRIS so that we can analyze the data, the feedstuff faster. And then we also collaborate with Ministry of Agriculture. Even we collaborate with industry and other institution abroad, yeah. Currently, we develop database with UC Davis under the faculty, yeah. We developed database to be able to integrate with the even advanced technology with multi-camera, yeah. So later on, we don't need NRIS, but we need a multispectral camera to analyze the data. But first, we need the database, yeah. We need to calculate. And this is the I think the last 5-year project that I work on, and with all development of database for feedstuff, yeah, using NRIS. And challenges we found during the data collection is the first, the inconsistent sampling and analysis method, yeah. This is a very difficult, especially if we collect the data from far away. For example, for the fresh forage, we need to measure them at the fresh condition and then dry them faster so that the quality will not with the fresh the forage is not spoiled, and then to reduce the dry matter and then send it to Bogor for the analysis. But this is sometimes quite difficult, yeah. And then in the local area, we found also limited access to lab infrastructure. And sometimes the farmer don't keep their record. For example, if we want to collect the grass, Napier grass from one area, if we want to ask how many harvests have been done, they don't have the record. So we don't, or how many days from the last harvest, it's also unknown. Sometimes it's difficult for the traceability, yeah. And also logistic challenges across the island is also difficult. How many minutes till I have, Bu Sari?
Just 3 minutes.
Oh, 3 minutes. Okay. And how the farmer use the feed data? Yeah, as I mentioned before, smallholder farmer will not use it because a smallholder farmer will not formulate their own ration, but cooperative will use the data. If we can put this on website like what we have in Dairy Feed online, then they can access the data. And also larger farmer use their own lab test, and then sometimes they only rely on the NRC, yeah. And this NRC, one is not based on the tropical area, the second is not based on our local feedstock, so there are many limitations. Sometimes they use old database, which is very irrelevant because of different climate change. With the climate change, the nutrient composition will also different, or is also, like I mentioned before, during dry season and wet season, is the data is also different. And feed miller usually rely on the standard data, but also lack of calibration. Like I mentioned before, if they rely on the imported database, then sometimes it's not fit well. So if we want to build a strong database, we need a collaborative platform. If we can build a single database where everybody can enter and join to input the database, then later we can get the stable database faster. Yeah, of course there is also like a gene bank. Yeah, everybody can put the data on the gene bank, so everybody can use it and enter the data. So it's also almost similar platform, but this is on a less or smaller scale. Yeah, I think that's all, Bu Sari. I will not go further with this for the for the conclusion. And we need reliable data as a foundation for the quality, efficiency, and sustainability. If you use wrong database, and then you will get wrong formula, and the performance of the animal will be cannot be controlled, or maybe you can release many waste to the environment. And Indonesia require our own national feed database because it's typical and also different from the stable or a famous database or existing database, which is very different in typical feeds type and also feed growth condition. And university, government, and industry can collaborate to build a faster and stronger database, and that everybody can use with different access, yeah, free access or limited access. And we can also invest in the instrument that can faster the database production, for example, using the NRIS, yeah. And this feed database can support national food security goals. If we can use the feedstock efficiently, we can get better production and less the excess of the nutrient to the environment. So I think that's all I can explain for today. I'm ready for the question. Thank you, Bu Sari.
Thank you, Prof. Despal, for the nice presentation. I think it is very, very important for our research development, and also for Indonesian, and also maybe for a developing country from Africa, Asia, and also in Europe. Okay, I will open for question, maybe 5 minutes until 15 minutes if you have any question about the data. You can raise virtual hand, or also write a question at a chat room. Is there any question? Yes, because it is really interesting for precision data for basic research and also combine a lot of information.
And maybe is there any of you who understand precision feeding? Have you ever heard about precision feeding? Jennifer, do you know about the precision feeding?
Yeah, Fadila wrote about yes.
Can
Answer
you
for
tell
the-
me a little bit what do you understand about the precision feeding? How we need the database for the precision feeding?
Hello, thank you very much for the presentation. So I've heard about it before, but I don't know, like, to my understanding is like in precision feeding, the feed is to be formulated based on the need of the animal and the quantity of feed. The animals should also be supplied the exact quantity. Like, for example, as we we feed ruminants based on their body weight. So in precision feeding, the exact nutrients requirements and the exact quantity of feed the animal need is supplied to the animal to prevent wastage of feed.
Yeah.
That's all I can.
Yeah, it's almost there. For the precision feeding, we need to give the animal the exact amount, the requirement, and but based on the individual requirement. And on the current feeding practice, usually they group the animal. For example, high producing animal is grouped in one, and so they have a one formula, and then middle group, and then so on. But in the precision feeding, we need to give the animal the amount based on their individual requirement. So how do we know the individual requirement? We need to collect the data, their body weight, their production, and so that we can calculate the requirement. And the ration is also need to be formulated based on daily and also based on the individual. So using the RFID, we can limit the access of the animal to the feedstuff. If the requirement already fulfilled, they cannot access the feedstuff anymore. So wherever they go, whether it is in the milking parlor or in the barn, the animal can only eat the amount they can eat, the allocation every day. So with using this, we need to know the exact the quality of the feedstuff, not based on the average. So to be able to formulate based on the exact requirement, we need to analyze the feedstuff faster on daily basis, right? How do we analyze the feedstuff on daily basis? We can use this NRIS, which equip with database. For example, using the NRIS, the inline or at-line database, we can scan, or using the handheld NRIS, we can scan the feedstuff. Oh, the quality is this, so that it will be go directly to the computer to formulate each animal. Yeah, how we can gather the information on the animal production, animal body weight in the precision farming, and the floor for the milking is equipped with the weighing scale. So when the animal go to the milking, and then the body weight will be measured, right? And then it will put into the computer. And the milk they produce can also be scanned for their quality and the amount, the total. So on daily basis, we get the information. This cow, the body weight is this, and the production in this, and then the quality milk they produce at this quality, so that we can formulate on daily basis their requirement. So this is the precision farming that already applied in many countries and nowadays. Of course, in under the developing country, such a system is not totally applied, but we can try to go near to this condition. Yeah, of course, we cannot measure the cattle body weight on daily basis if we use a manual milking. because the waging is only applied if we have a for example robotic milking machine that equipped with the what you call it, waging scale. Yeah, so in the principle, precision feeding, it's mean we fed the animal exactly the amount they require daily, not more, not less. So it's mean the access to the environment will be less. If we fed the animal based on the average, the group, some animal is underfeeding, some animal is overfeeding, right? And it's mean the underfeeding will not reach their maximum potential. The overfeeding will will excrete the nutrient to the environment. Yeah, is it clear? So to be able to use this precision feeding, it's only possible if we have database, because we need to calculate that ration on daily basis, right? It's computerized. Is there any question? Or you, I don't know whether
I
you
have
have, yeah.
I wanted to ask, like, for example, you said Indonesia is a tropical country, and for the database, I don't know if you entertain like composition of feed ingredients from other countries to like have more data to compile for the tropical regions. Like if a different country from Indonesia, which is a tropical country, wants to like send information on feed ingredients, do the committee for the data compilation accept like data from other countries that are in the tropic for this compilation of the data?
Yeah, the people, it's like this. If we want to develop global database, we need to entry many data from different region, right? So that it can cover, it can be used in different area. But if you want to use the specific database for certain area, then it will be more accurate, but it's less practical. Now what we want to build a global database that can be used by many countries, then everybody can enter and join the database development. But the problem is the accuracy will be less.
Yes,
Yeah.
definitely. Yes.
Sometimes like NRC, most of Indonesian ration formulation nowadays still rely on NRC from US. Yeah, but because many of ingredient we use in livestock in Indonesia is also imported. Yeah, so for this feedstuff, NRC is sometimes is still accurate, but for local feedstuff, it's not covered in the NRC. Therefore, we need to develop our own. But if some country, for example, from your country, also have a similar feedstuff with almost similar characteristic of the region, then you can use also this kind of feedstuff. Therefore, in choosing database, you need to know the characteristic, which one is more relevant and more suitable for the condition, for your condition. We can build also for example, a humid tropic database. Of course, dry tropic like in your country is kind of join. But if we talk about tropical area, because tropic, there's a humid tropic, there's a dry tropic, right? And it's also very different.
Dry tropic.
Yeah.
Nigeria is dry.
Yeah, dry tropic is quite different. Humid tropic, we are very, what you call it? There are many biomass, the rapid growth of plant, but it's very fast to build the lignocellulosic material, yeah, because it's aging faster. Yeah, in dry tropic, I don't know whether it is worse or better, but it's slower growing, yeah, because less of
Yes.
water available.
Yes, the moisture content is low, then the fiber content it used to be high.
Yeah,
If the forage is harvested as like late harvesting, but if it is early, the nutrient composition is better
yeah.
and the fiber is lower.
But
So
for
thank you
us,
very much.
yeah. Okay.
Okay, thank you from Fadila. So, Prof. Despal, there is two questions from chat
Oh, okay.
from Zaidan and also from Sarifah Aulia.
From Zaidan. Okay. About biotechnology, how can RNA interference or CRISPR-based gene editing be applied to reduce leaking biosynthesis and tropical forage crop, and how this modification will impact? This technology you can ask Busari Komalasari because he's an agroecology, yeah. I'm dairy nutritionist. I'm not really work with the grass biotechnology, yeah, or gene editing, but we can modify it or we can improve the quality of the forage. But the problem is if we reduce the lignocellulosic material, then the grass is easily fall down because a high wind, yeah. For example, we have the Napier grass from Taiwan with higher protein content, lower fiber, but after 2 or 3 harvests, it cannot stand up anymore because it's very low, what you call it, with a strong wind, and then it is difficult to, what you call it, apa tuh Bu Sari kalau dipanen berkali-kali?
Ratun.
Yeah, the foliage, yeah, multiple foliage, and then it's not more foliage, harvesting, multiple harvest. It's a but the advantage of our Navia grass is we can harvest until several years, yeah, and without tillage. So there are advantage and disadvantage for the modified what you call it, forage. It can improve their quality, lower the fiber, but the problem is how they can survive, yeah, in the strong wind in the field. So it's also one category. But of course, if we want to produce for the pasture, and it's another story, yeah. For the cut and carry, we need a strong plant that can resist wind and also can be harvest multiple. And from another,
From Sarifah,
from Saripa,
how are laboratory tested data?
how the laboratory test data or NRC estimate, yeah. If the data is, if the feedstuff is imported feedstuff, of course, NRC is more accurate, yeah, because it's generated from more than 1,000 analysis. But if it is local data, local feedstuff, then our local analysis is more accurate because they don't analyze for example, tofu waste. They don't have a tofu waste in NRC database, yeah, sometimes. Like this specific local feedstuff, we need our own laboratory. But for daily use, we need to test our feedstuff regularly because even the same name, the same if it is imported feedstuff come from the large factory, usually their data is very stable, their quality is quite stable. For example, Pollard is quite stable. The variation is very small. We can use the NRC. But like rice bran, especially rice bran from small miller, and then the quality is very, the variation is very high. Yeah. So this is depend on whether it's laboratory, it's better than the NRC, yeah. And Jayden, oh, okay. yeah, biotechnology is always good, yeah. We can modify it or we can improve the current condition, but the cost effective and technical effective of their what you call it application is need also to be considered. Sometimes we can produce a better plant or better animal with biotechnology, but if we distribute them in the wild, then they cannot survive. So sometimes biotechnology need also be accompanied by their survival rate. Yeah,
Okay, Prof.
I think
Despal.
yeah,
Yes.
I think that's
Eh,
all. If
Yeah.
there's more
There's a lot of
question,
interesting
I
discussion,
will be
I think.
happy to answer. You can directly contact me.
Okay, thank you, Prof. Despal. It's already 15:18 in Indonesia, so we give appreciation for Prof. Despal with reaction or emoticon, I think. Thank you, Prof. Despal, for interesting topic, and I think a lot of us want to learn more, but time is over, and I think Raden already called me.
Okay, thank you. Enjoy
Yeah.
your stay and collaborate with your college, and hopefully you gain some experience. Yes. Okay. Bye-bye. Thank you.
Thank you, Prof. Despal. Okay, we already finished our second presentation, and thank you for all of participants. And I give the time to, and the screen to Raden. Thank you, Raden.
Okay, thank you very much, Dr. Sari, for leading today's insightful session. And of course, a big thank you as well to our speaker, Professor Anuraga and Professor Despal. Actually, I am one of Professor Despal's student. Hello, Professor Despal. And I also want to say thank you to all participants for your attention and active engagement throughout the course. Before we end, I would like to remind you a few important announcements. So the first, please make sure to complete the assignment they share on OCW, and don't forget to submit it according to the deadline stated. And the second, we will continue with the next session for our international summer course tomorrow at 1 p.m. Western Indonesian time. So please be on time and stay excited for another insightful topic. That concludes our session for today. Thank you once again for your participation and enthusiasm. I am Raden, signing off as today's host. Have a wonderful day ahead and see you tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.
Indonesia, the biggest archipelagic country on Earth. Made up of thousands of volcanic islands, best known for beaches, volcanoes, Komodo dragons, orangutans sheltering elephants, and tigers. The mega biodiverse country is inhabited by 20,000 different kinds of herbs and plants, also place where you can find more than 10,000 kinds of animals roaming the land. Indonesia is homeland to hundreds of ethnic groups speaking as many as 650 different languages. Differences is our motto, made us strong by one vision of a big country. Formerly part of University of Indonesia, in 1963, IPB University was stood as the first independent campus to focus on agriculture. Located in Bogor, West Java, IEPB University brings strong vision as a leading international university focusing on agriculture, marine, and biosciences.